Hey everybody, this is Larry. This is day 19 of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Maximum product of split binary tree. I usually solve these live, so if it's a little bit slow, just watch it on a faster speed, skip forward, whatever you need to do, as I kind of go over my thought process as I look at these problems. So the first thing I noticed is just scanning it. I noticed the mod. One thing that I'm really bad at is that I keep forgetting about the mod, so I'm just gonna put that here so that I don't forget it and get a wrong answer. That's a little bit sad. It's always a little bit sad when you do competitive, especially, and you forget the mod because that is a quick, easy 5-minute penalty, and that's just sad. Okay. Let's actually read the problem. Given the root of a tree experience by removing one edge such that the product of the sums of the subtrees are maximized. Okay. Return the maximum product of the sum of the two subtrees. Okay. Okay, so the mod part actually doesn't come into play that much in... maybe it does. This is a little bit awkward in general. It's a little bit awkward in general because... Oh wait, the maximum of the sum. Sorry, I thought it was for some reason products. Okay, so the sum is not that bad. Then yeah, the mod doesn't really come into play except for because everything should fit in a 64-bit integer. Even signed, you could use unsigned if you like, but should be signed is okay. Though actually, is there negative numbers? Now there are no negative numbers. So, oh wait, yeah, no negative numbers. So yeah. So the thing that I would go about attacking this is kind of let's see. Well, I mean, the thing that I would go about attacking this is try to figure out a way to brute force this. Naive brute force is probably going to be n square. I don't know that I have a proof or even a strategy for that, but just kind of well, I guess the naive way is just physically removing the edge and then literally do 2 depth of search or something like that, and then kind of figure that out. And that's gonna be n squared. I assume that n squared is gonna be too slow because it's 10 to the 4th. So now we're trying to do something with O of n, and I think I said it in a recent video. O of n log n doesn't come up that often on elementary tree problems. Like I know that there's binary lifting, there's type things, and there are things that mix it n log n, but it just doesn't come up that often. So I'm thinking about linear and some way of kind of brute forcing it, or like brute force, but in a smart way. And so I think the way that I can do this then is okay, realizing 2 things. One is that the sum of the entire tree, right? Because you're looking at sum of 2 subtrees, but that means that we do a depth first search or just like a regular traversal of the tree, then we get the sum of 1 tree, and then now once we or the entire tree, and then now you could split it up into 2 trees by doing a regular depth first search, because then now you have you can get the total of every subtree. And in that sense, you can kind of do the math that way. I probably didn't say that quite right, but if you're able to kind of build from the grounds up, from the leaf up, of sum of everything, the sum of a node and or its descendants, then you treat that as being equivalent to removing the node to its parent, right? So okay, let me actually, I think I got the answer. So hang on, let me bring up. Let me bring up Paint so that I can kind of visualize this a little bit for y'all. But basically, let's say you have some tree. Now you have some tree. This is an awful looking tree, but oops, that literally was off the screen. But okay, something like that, right? So now we know the sum of the tree because we just calculated. You could do that in linear time. And then I would construct a second search where I return, let's say we have, let's say we want to calculate this subtree, then we can probably, and there is an easy way to calculate just the sum of, this node, this node, this node, and in that case, you can, do some magic to kind of get the sum of this. And if you have the sum of the red box, you could calculate the sum of everything outside the red box because they add up to the total of the entire tree. And therefore, you can treat getting the sum of this red box as cutting it off. Let me change another color real quick. Cutting off. Do I use green and red in reverse order? Well, okay. But yeah, but basically, you could treat having the sum of the sub box equals to getting rid of the parent node, right? In this way. So in this way, I think that should be sufficient to, to go about it. So I think this mod doesn't come in that much because it fits in the 64 inch. So we'll just keep it at the way. And but yeah, so let's get sum. So let's just say total of. You can do it once, you can do it twice. I'm trying to think what's the smartest way of doing it. Because you can, in theory, you could do it in one pass, but yeah, you can do it in one pass and you can play some funky things with it. I'm just going to keep it simple for now, and just do it in 2 passes. Hope that's okay. Yeah, you can do it one pass for sure. But then you have to do it more maths around it, so it's a little bit weird. But yeah. Ah, this is optional. Huh. Is that new? I feel like I've never seen an optional before. But that also means that... Okay, I was going to say that usually you only want an optional as an input if the number of nodes can be 0, meaning that this can be nullable. Knowable, nullable. But that's a really awkward thing because there's at least 2 nodes. So, okay, either way. And return 0, otherwise return node.value plus total of node.left plus total of node.right, right? This is pretty straightforward, totaling the tree depth first search, or in this case pre-order traversal. And then now we go the second loop of, to be honest, it's kind of awkward because I do it's literally the same code, but a little bit different. In that we add an extra statement. Maybe I could put in one thing, but I could do in one thing, but it doesn't really make sense to put in one thing because I could add a parameter that's like boolean update or something like that. But I don't know. Let's just say find max, right? So in this case we return none. But then the only thing that's different about this is that now we have, this is the subtree total, right? So subtree sum is equal to this thing. And then now you can do something like, let's just, naming things is hard, that's what I got. But okay, tree sum is equal to total of root. And then now you can do it in 2 ways. You can either pass in the tree sum here if you like, or you can just, I don't know, it doesn't really matter. And then here we can just have best is equal to 0, and then at the very end we do best mod. And here we don't need to do, you can if you, actually I don't think you can because that may lead to some weirdness, but you can actually, you don't need to mod until the end because, like I said, everything should be fitting in a 64-bit integer anyway. So, okay. So best is equal to the max of the best subtree sum times tree sum minus subtree sum, because this is basically everything that is not in the subtree. So then, yeah, I think I have to do non-local best, and I think this should be good. And in this case, I think the function is a little bit weird, to be honest. I don't think my code is as clean OOP as I would like it to be. But, you know, let's get it, let's see if it works first before I clean up the code, right? Well, that's not good. Dong dong dong. Well, something's just not working. Oh, no, that's not true. That's right. Let's print this out first. Am I getting the sum correctly? The sum seems correct. So that looks okay. So then it's my find max thing. By max of no some huh. Dong dong dong. Oh, I see. No, do I? Alright, let's just print it out then. Why is that? Well, that's the entire node, but this should be happening. Oh, I am just being dumb. That's what happens when you copy and paste. I actually want to do this recursively, right? Because we want to go up and down the entire tree recursively. And okay, now there we go. So let that be a lesson to you. Don't copy and paste, even though I did do that there, because sometimes you miss silly things like this. Okay, so I think I'm actually pretty confident about this. So let's give it a submit. And part of the reason why I'm confident is because I know that this is linear, right? This is linear because, and check out accepted. This is linear because we just do 2 passes, and each of these is a tree traversal, which is linear. In terms of space, this is O of h, where h is the height of the tree, because again, you have the core stack, so it's gonna, I'm not gonna go over core stack in this video because that's just intense, but definitely Google that up if you have questions about the O of h space. But yeah, let me know what you think. Let me frame this in a good way. Let me know what you think. Hope y'all have a great rest of the week. Happy Thursday. Stay good, stay healthy. I hope I see you tomorrow. To good mental health, and I'll see you later. Bye bye.